Policy and a Sustainability Manager at Sky Energy. We also have Anton Fagerström, who is a Senior Project Manager at IVL. We also have Fredrik Granberg, Project Manager at Luleå University of Technology, and Kjell Andersson, who is Communications and Policy Director at Svebio. So as you can see, a very knowledgeable panel, and they will help us finding out more and digging deeper into the questions about SAF, the availability, and also about regulations and certifications and feedstock. So to start off with, I would like to invite Magdalena to take over the floor. Please, Magdalena, introduce yourself and tell us a little bit more about Neste.
Oh, thank you so much. I'm so happy to be here and discussing this really, really important topic. As we know, aviation is struggling hard when it comes to COVID-19, but I think we all agree that in this recovery of the aviation, it needs to be green recovery. And there are solutions here and now, and one of them is SAF, and there will be other solutions also for the future. I'm working for Neste. It's a global company headquartered in Finland, one of the biggest, largest producer of biofuels in the world. We do renewable diesel for road transportations. We recycle polymers and chemicals, but also producing SAF or biojet, as you can call it as well. And I don't know. It's just do you want me to tell me more about the production? Because we actually have production here and now in Sweden, and for both Sweden and other markets as well. But maybe I should stop there and then tell you more about that.
All right. Actually, we'd be interested to hear that, and of course, how much you can produce today, and what's in the pipeline, how much you're about to produce, and yeah. So
I'm happy to. Yes, thank you, David, for that question. So today, actually, we are producing SAF up with the capacity up to 100,000 tons per year in Porvoo, Finland. But for 2023, we will have the capacity to produce 1.5 million tons per year. And we will not stop there, because we see there will be a huge demand for biofuels and for SAF. So we will actually take also a investment decision next year to increase our production in Europe, and we hopefully to start that production 2025. So right now up to 100,000, 1.5 million 2023, and then 2025 even more. So and then we can discuss raw materials and so on. Will there be enough, and is it sustainable, and so on? But sometimes, you know, there is not enough SAF, or there is no SAF. Yes, it is, and there will be more in the future as well. So I would say that the solution is here and now, and we can use it.
That is great. So how do you guarantee sustainability today? On the products.
Okay, good. Yeah, I think that's super important, because we have a discussion and debate, at least in Sweden and other countries as well, if really biofuels is that sustainable or not. First of all, I would say if you use our SAF, that will reduce the GHG emissions with up to 80% compared to fossil fuel. Sometimes you have to also ask, you know, how sustainable is actually fossil fuel. With that said, you know, our raw materials, they are certified, verified by a third party. That's, you know, is required, of course, accordingly to the EU legislation as well, when it comes to sustainability criteria for biofuels, liquid biofuels. With that said, being actually seen as one of the most sustainable companies in the world, accordingly to the Global 100 list, we work, of course, also beyond the certifications. That's not enough. So for all our suppliers, they need to also comply with our code of conduct and different policies around human rights, sustainability, sourcing, and so on. We also have full traceability for all all our raw materials. We also, we actually on the ground in those parts where we actually source our raw materials, so we can support our suppliers, but also work together with local NGOs and others. So if there is, if the suppliers are not following our contract and the policies, it's good that we get those kind of information, and we take that really seriously and investigate all those kind of problems and accusations, and during that time we don't source from them, and following up again and again, and have own audits. So I think when we work with raw materials in also quite problematic areas, I think it's super important that it's not 100% perfect, but you need to work more and more and do better and better. And when it comes to raw materials, I will also say today and also in the future, we use only 100% waste and residues. So no palm oil or no PFAD. So mostly use cooking oil and animal fats. So.
Thank you so much, Magdalena. I think we might come back and touch that subject about palm oil and residues from palm oil, because that is a subject that is high on the agenda. So again, thank you very much. I would now also like to invite in Caroline Arts from Sky Energy. Please, Caroline, can you tell us a little bit more about Sky Energy and the work that you do?
Sure, definitely. Hi, everybody. Great to have you here. Great for this opportunity. I will tell you a bit more about Sky Energy by sharing some slides with you, so you have some visuals. So maybe that's a bit handy for this one. If the host can enable me for screen sharing, that would be wonderful.
Hard on it.
No worries. I see you have multiple screens. It looks complex. Take your time.
So there you go.
Yes, that looks great. I will have a look. I need to share. Windows. Yes, we're there. So I will make sure it goes on the big screen. Yes, we're there. Hopefully everybody can see the beginning, the first screen, Sky Energy at a glance. I will continue from here. So, Sky Energy was founded quite some time ago. The reason why Sky Energy was founded was actually because an airline, KLM, they conducted an investigation into what is the majority of our carbon footprint. Where does that emerge? And of course, one of the conclusions, or the conclusion, was that the majority of the carbon footprint came from the combustion of fossil kerosene. So with that realization, it was more than 99% of the footprint of the airline itself. They realized they had to do something about the fossil kerosene part in their chain, in their supply chain. Therefore, they joined forces with Argos, so a major oil company, and together with a sustainable consultancy entity in Amsterdam, Spring Associates. And that was actually the beginning of Sky Energy. And Sky Energy was there this was really at the beginning of the SAF industry. So maybe it's good to know the context that sustainable aviation fuel wasn't there. It had to be built from scratch. It had to be defined from scratch. So if you replace fossil kerosene, with what should you replace it? And also, when is something sustainable? What are the rules behind, for example, feedstock sourcing? What should you be looking at for the supply chain? Can we just blend it with fossil kerosene? Can it be fueled into the wing of a plane directly? Is new infrastructure, is that necessary? So all these questions were in the beginning of the SAF industry, because there was nothing there. So we were literally there building the industry from scratch. Ever since, we supplied more than 30 airlines all over the world. Of course, started also partnerships because since the beginning, we of course knew the importance of replacing fossil kerosene with a sustainable alternative, and that's why we joined this project. You already see, for example, in around 2030, RSB certification. So RSB is considered by the aviation sector as the gold standard when it comes to third-party certification. So they're really strict at the social and environmental criteria to guarantee the social and environmental sustainability of the fuel. So we were also a founding partner of this roundtable, which actually built their standards in the stakeholder process, because of course sustainable aviation fuel was new. So how to define that something is sustainable? So we were there since the beginning, and slowly we built up this legacy in this field. We also realized after some years progressed, some of you are quite familiar, I think, with this picture. It's often used. What it actually says is we as aviation sector, we have really clear targets. So in 2050, we at least want a 50% reduction, carbon reduction compared to the 2005 baseline. So that's a really strict target, but of course, how to manage this. So the first line you see all the way up with all the dots, that's no action. But of course, we've been taking action for a really long time. So airplane efficiency, you name it, and that's the gray area you see. So that's efficiency improvements. Then actually you're not even, so even if you follow the trajectory of 1.5% efficiency gain for airplanes itself and for the burning of fuel, then you're not even reaching the same amount of emissions. So even if you want to go to the minus 50%, there are new inventions indeed which must step into the game, and that's of course the sustainable fuels and new technologies. So new technologies is electrification, hydrogen, etc. But the majority, so big important part is being put to the sustainable aviation fuels. So it's quite crucial that we develop this pathway as fast as we can. So this is kind of the developments we see. So in the beginning, it was primarily single commercial test flights, of course. So you see 2008. So imagine that the study of KLM was in 2007. So this was really in the beginning. We first had to prove that SAF was safe, and of course that it could be technically certified. Then ASTM came into the play. Well, so in the beginning, it was more proving that you can fly on sustainable aviation fuel. Over the years, we saw a series indeed of commercial flights, and now we see supply chain initiatives. So for example, there's a flight from Amsterdam to Växjö, and that's fully sustainable ongoing. And also the flights, for example, once more from KLM between Amsterdam and Los Angeles are also on sustainable aviation fuel itself. So these are constant ongoing. Every flight, there is sustainable aviation fuel in the tank. So what you see at Sky Energy, so we moved from so the short-term activities were really in the beginning, it was more a challenge. What is sustainable aviation fuel? How to define it? How to create it? Logistics, etc. Prove that it's safe, prove that it's sustainable, how to prove that it's sustainable. And now we're slowly moving towards new set of activities. And that, of course, has to do with the production side. So we see over the last 10 years, it has been a voluntary market. So you as an airline can decide whether to buy it or not, but there's a price gap. So not a lot of entities are buying it because it's with the most commercial SAF technology pathway, it's 2 to 3 times as expensive as the fossil kerosene alternative. So and we see the takeoff of sustainable aviation fuel is not going so steep as we would expect it. That's why we thought it's really important to definitely, as Magdalena also said, to look at the production side to ramp that up. That's the reason why we're also building a facility in the Netherlands, which will be live in 2023, around 2023. And this is a facility which has as main product sustainable aviation fuel. So what you normally see is, as a producer, you produce multiple products. So for example, can be renewable diesel and then a bit of SAF or a bit of whatever naphtha, so you can have multiple products. And what we see right now is that many facilities, the main product, so the main output is, for example, often renewable diesel, because then has more profit, makes more sense because it's also an obligated market. But we will make sure that the main output of this facility will be sustainable aviation fuel. So in that sense, also moving towards that direction, because we know the production side is quite crucial. So the idea is why it's called DSL. It means direct supply line. So we want to look at local feedstocks, local supply chains, and therefore with DSL Netherlands, we will analyze which feedstocks make sense for the Netherlands. And then, for example, if there's a DSL 2, 3, if there are in different regions, we will look per region what makes sense. So that's kind of how we imagine the scale up of the direct supply chain. What I already said, so there's the price gap. And this is quite crucial. And this is, of course, also quite crucial, and why we initiated with the other part is the Fly Green Fund, but also the KLM biofuel program, also BorgNow, etc. Is because, of course, we have to bridge this price gap, because otherwise the fuel would never be there. So it's really crucial also for individuals to support, for example, the Fly Green Fund, so we can start scaling up this industry step by step, especially as there's not a lot of policy mechanisms yet. We will probably get to there, so it's pretty EU-wise mandate system will be in place. And of course, Sweden already showed their front-runner position also in these decisions by taking on this mandate. So there are some developments, but before the situation that there were no policy or no concrete or tangible policy mechanisms, the Fly Green Fund initiatives were really crucial, and still are, because there's still quite a low demand on it. To finalize just this short introduction is, of course, sustainability is key. It's definitely key. So what I said, we were there since the beginning as a stakeholder of RSB, defining the standards also on social welfare. So think about labor rights, human rights. Is somebody paid well? What are their working conditions? What about land ownership? So if you enter a field where there's people living from, for example, forest themselves, what to do with the forest, shouldn't we touch it? Well, it's also on the social side, but of course also on the environmental side. And next to that, it's really crucial. We have a sustainability board consisting of major NGOs and academics. So every feedstock we use, we first must get approval from them. So nothing continues without their approval, and that's really crucial. And that's also giving us a better understanding and the complexity of every issue. So they're quite crucial. So we do not touch palm or any of the residues, because we know this market is saturated. Also with UCO, we see this market is almost saturated. So if possible, we should step away from this feedstock as soon as possible. Well, so all these visions actually come from, of course, also this interaction with sustainability boards. And then everywhere we go, so for example, if there's a project in South Africa, we first have communication with the NGOs which are located there, because they have a lot of tips, hints, things that we should look into, which we otherwise wouldn't have. So definitely learning by the local NGOs as well. That's for now, I think, in a nutshell, Sky Energy, where we came from, where we're working towards, and what our mission and vision are.
Thank you. There was, I think you answered most of the questions that I had planned to ask. So I think what we've been hearing now is what's on the market right now, and how it's done today. Interesting to hear, though, is what other kind of fuels there are out there. And one technology that's coming up is electrofuels, and we're going to let Anton present electrofuels.
Yes, Anton Fagerström, please take over the scene. And again, thank you very much, Caroline. You ended up in some of the questions that we will be getting back to a little bit later on, about certification and about how we can rely on the fuels actually being properly sustainable. In the meantime, Anton.
Yes, thank you.
Had a slide showing
Will
up.
you share my slide, or would you like me to do it?
If you have it available, I could give you the.
Yes, please do, Anton.
Yeah, sure.
You have to let me. And we'll let you in through the right computer.
Actually, now that Colleen is the host.
Okay, a little bit of technical issues. Caroline, can you let him in?
Yes, I'm looking with you. I see I can admit people into the room. Maybe I should do as well. I'm afraid I cannot de-host myself.
Well, welcome on board then. You'll be our admin, our technical support.
I also have to admit a lot of people who want to enter this session, so I'm admitting them all.
Thank you very much.
Yeah, I'm unable to share my screen in the current stage, it seems.
Okay. Would you be okay to start?
Yeah, sure. I can start talking.
While we're looking into if we can solve the technical
Oh,
problems.
maybe you can do right now. Sorry, Anton, I found a function multiple participants can share simultaneously. Can you now share?
Let's see.
Yes, great.
Yes, there we go.
Great.
Thank you,
I'll try
Caroline.
to expand it as well. Do you see the picture now? Now you see my. Yeah, well, I will stop sharing right now and I will start speaking instead, and then I will share once that comes up. Well, thank you for inviting me, first of all. I think this topic that we're discussing today has been getting a lot of attention lately, and many ideas are currently being discussed. And in particular, we at the IVL, the Swedish Environmental Research Institute, are currently working together with Jämtkraft, the power region, Östersund kommun, Lund University, Chalmers University, and Nordic Initiative for Sustainable Aviation, and also Fly Green Fund in a joint feasibility study called Large Scale Bioelectric Jet Fuel Production Integration at CHP plant in Östersund, Sweden. And this project has been going on for 1.5 years now, and it will be finalized by the turn of the year. And the results are promising, and we are currently setting up a consortia for the continuation in one shape or form. So I've been asked to describe a little bit what electric fuels or synthetic fuels are. So I will try to share my screen now again. See if it works. So electric fuels is a combination of carbon dioxide and hydrogen, and this is an example from our particular project. Basically, it's divided into 5 steps. So first of all, it's the production of carbon dioxide, which you see as a CHP in the left box on the screen. And then this is then where the actual carbon dioxide, which is biogenic in our case, is produced. Then there's the production of hydrogen, which is then the formation of hydrogen through electrolysis from water and electricity. And then the carbon dioxide is captured, of course, in a dedicated process for this from the flue gases from the point source of carbon dioxide, the CHP in our plant. And then the hydrogen and carbon dioxide is combined in a synthesis process where the electrofuel is produced. And in our project, we are looking into two separate pathways. It's either the established Fischer-Tropsch pathway and modified alcohol to jet through methanol synthesis pathway. And after the synthesis, you produce an biocrude or an electrocrude in our case, which you then need to separate through a refinery, some kind of refinery process, and that will then be divided into different fractions, of which the biojet or electrojet is one of them. But even if the process is optimized towards jet fuel fractions, you will also simultaneously produce e-diesel and e-petrol to some extent.
Thank you. When do you expect a full-scale production being available? Could you give us a prediction?
You hear and you see different things in different studies and reports and journal articles and so on, but based on our findings, and if you base it on the available technologies that are there today, I would say full-scale industrial production would be possible in the range maybe 4 to 8 years, because, as I said, the separate techniques are matured and available, but they're not really combined at this scale for this particular purpose just yet. So the first plant that do that needs to be built at industrial scale.
And price-wise, I mean, SAF is extremely expensive today. When will it, or how will the price develop, you think? This particular fuel, that is.
For the electrofuel fraction, I would say there was a report launched last week, I think, from the World Economic Forum, where they had some predictions, and I would say our predictions are much lower than they are. So at the current technology level, I would say that the production costs scale almost linearly with electricity price predictions. So if favorable conditions apply, meaning then that you have a very good site where you have a good point source of green carbon dioxide, and you have cheap or plenty of cheap and renewable electricity available, and you have the available power at close to the vicinity that you plan to build a site, I would say that, and this applies to lots of places in the Nordic region at least, the initial costs could be somewhere in the order maybe 1.5 to 2.5 euros per liter. And then they could decrease further as more efficient electrolyzers become available. But of course, if you have less favorable conditions, you don't have these good things going for the actual site, then the production costs can be considerably higher. And the most important part of the production cost is the price of the electricity itself. So OPEX is high for these kinds of installation compared to CAPEX.
And carbon reduction wise, what do you expect?
If you have these good point sources of biogenic carbon dioxide, and if you use completely renewable electricity from PV, solar, or wind, or hydro, it's possible to produce e-fuels with very low environmental impact. And our calculations show that we are possible today to reach even more than 90% reduction, or at least close to 90%, and that could be reduced even further. And that would correspond to somewhere in the range between 8 to 12 maybe grams of carbon dioxide equivalents per megajoules of fuel.
That sounds
very interesting.
That sounds very interesting. Yeah. Yes, and just to round it off, would you say that that is the main issue, being able to have enough green energy, green electricity to scale up production? Is that the biggest hurdle?
I mean, to be able to get this kind of numbers, you need to be able to use all the energy and mass flows in a very efficient way to get the efficiency for the complete process up. And then you need that, and you also need access to good points also of carbon dioxide and plenty of electricity. So all these conditions to apply, for example, you need to be able to find usage for all the residual heat that you get in the process and so on. The number of sites where you can do that is probably limited. So that's maybe the limiting factor for scale up, or what you would say.
Okay, thank you very much. We will get back to you. But now I would like to move on to and welcome Fredrik Granberg. Please enter the scene. The floor is yours, Fredrik. We would like to hear a little bit about, well, of course, you, but also the initiatives and projects that you have been involved in from Luleå Tekniska University, and also your thoughts about the availability of feedstock and how we can maybe produce feedstock locally in Sweden, SAF locally in Sweden, of course.
Yeah, okay, thank you. Yeah, my name is Fredrik Granberg, and as you introduced me, I'm working as project manager at the Luleå University at the Energy Division and Division of Energy Science in Luleå. And well, I've been working with sustainable aviation fuels since around 2017 with some partners, and in a project led by IVL, and it was Vinnova funded, looking to the tech evaluation of suitable technologies for a Swedish perspective based on forest residues and renewable sources in Sweden. And after that, and right now actually that is ongoing, we work on a pre-study where we look especially on the gasification and Fischer-Tropsch case towards sustainable aviation fuel from forest biomass. And that study we look on. We're doing engineering for a pilot test production site, producing 1 ton of stuff per day from forest biomass. So that's very exciting. I think some people attending the meeting today are involved in that and know more about it. And well, a bit more about my history. I've been working with gasification. That's why that is my core interest also since 2005. And then later also with synthesis technology, not towards SAF that started that interesting in 2017, as I said. But I have some practical experience from gasification and synthesis. And yeah, what I've been involved in more, just a small part for myself, but some part from a colleague at the university in the study performed in Småland, flying on forest residues in Småland. So I would say I'm not really an expert in feedstock sourcing and availability, but I've been looking more on a broader perspective, also technology and feedstock, and so on. And I would also like to mention actually another project that I'm working with right now that is very interesting, with the name CREPower. It's a project with stakeholders up here in northern part of Sweden, where we look into the preconditions really for a biorefinery. We focus on production of sustainable aviation fuel. So we have industry, institutes, and municipalities involved in that. So it's really important to look on these preconditions. So we have actually, you can look into our website, the crepower.se website, and see what we are doing in that part. Yeah, so that's a little bit what's going on and what I have been doing. So you wanted me to discuss more about what?
No, but it's thank you. And I know earlier, a couple of years ago, you presented figures showing that you could easily make at least all domestic airline flying in Sweden fossil free or carbon neutral, or well, powered by biofuels at least. So it's anything to say about that?
Yeah, what do you say about that? Yeah, of course, we need to remember when we talk about the theoretical potential and then what really will be practical and economical, so to say, those are different things. But if we look in Sweden, I mean, we consume about 1 million tons of fuel for the aviation, both for the national and international, or the domestic flights and international flights. And for the domestic flights, well, it's around something like 250,000 tons fuel needed. And if you look on the forest industry, some of our research and in the projects we have found that there is a potential about 28 to 43 terawatt hours of forest residue potential. So that's a quite wide spectrum, but there is some uncertainty how much you really can access, so to say, and how much you need to leave in the forest. There is a debate about that. And if you take that and convert it, you could produce, if you use the Fischer-Tropsch pathway, it would, if you take the high number, you could produce via actually the existing pulp mills that we have. So you swap out the black liquor or a byproduct from pulp industry with forest residue for keeping the energy balance in the pulp mills. You could produce about 750,000 tons of stuff. But that's the theoretical potential. And that would, of course, fulfill the demand well enough for the domestic flights, but not really for the total need. But
No.
as you also heard from Anton, then if we, I mean, with the technology, we lose actually a lot of carbon. So if we could access hydrogen, then we could utilize more of the carbon from the biomass and actually more than double the amount of fuel than what I just said. So it would be 1.4 million or 1.5 million tons of SAF as a theoretical potential. And if we then also add other carbon sources, yeah, I think we have resources so that we could produce what we need. But that's also the theoretical. Then we'll see what will be practical and doable in financial terms.
But I think you sort of targeted what we're talking about today, because yes, of course, we would like to see how theory meets what we in reality actually can produce.
Yeah.
And it is still interesting. And I think also because, well, when you presented these figures a couple of years ago, that we, for example, Sweden not being the largest country, but that we could be self-sufficient, and also that the benefits are that you don't have, the feedstock is sort of on your doorstep, and that you can combine it with other industries. So yes, again, and I also think this is a good bridge over to welcome Kjell Andersson at Svebio, because
I would like to add one thing on just to these numbers when you think about efficiencies. Now we mentioned the sustainable aviation fuel, but if you do the Fischer-Tropsch pathway, you would co-produce naphtha suitable for biogasoline and also bio-LPG in the Fischer-Tropsch case. So it's not only this aviation fuel that will come out. And then we have other promising pathways. I mean, we have alcohol to jet, and we have what we call about power to liquids and so on. So there are different interesting pathways. Yeah. Thank you
very much, Fredrik. So Kjell, are you with us?
Yes, I'm here.
Welcome.
And I think you had the pictures for me. I may comment a little bit on what Fredrik said, that I haven't prepared really pictures for the Swedish supply, but we use today about 150 terawatt hours of bioenergy in Sweden. And we are certain that we could increase that level to around 250 at least from both forest and agriculture. But I have taken more of a global perspective here. You know, often people say like this, that biomass is a limited resource. This has become something of a truth in the last few years from everyone who is speaking. But I would like to say that this is not true. It is the fossil fuels that are the limited resource, because they will be depleted, and they are the ones, with the combustion of them, we threaten the climate. Biofuels are renewable, and the biomass resource is not limited. Biomass can be produced indefinitely, just like wind and solar, as long as they are produced sustainably. I mean, you could think of this, that forests can be there for 10 million years in the future, whereas the fossil fuels will be depleted. They are part of the natural carbon cycle, and they don't contribute to global warming, as long as we safeguard the green carbon stocks, of course. We have to keep the stock at the same level, but we can produce more and more if we have better systems. The main issue here is not how big the total potential is, but how quickly we can increase the production and mobilize resources from this biomass basis. Next picture. We haven't seen so many studies on the total bioenergy potential globally, but this is one. It's from IRENA, the International Renewable Energy Agency. And this was for 2030. And the total global potential, they said, was 147 exajoule. Take the next picture, maybe. If we compare that to the global energy use today, which is about 450 exajoule, this is about 1/3 of all energy use today. But this is only up to 2030. So it's actually the kind of potential that could be mobilized relatively quickly around the world. It's as much as 52,920 terawatt hours. So it's quite a lot. The aviation energy use is about 14, so it's about 1/10 of the total global biomass potential. This includes, we could have seen that on the other picture, but it includes both crops, it includes forest products, it includes wastes and residues of different kinds. Of course, this one condition here is that we actually use agricultural land also for growing crops, which is disincentivized, for example, in Europe today. And IRENA, I already said that. We can look at another picture. There are even bigger potentials, and this was a report a few years earlier, rather much based on Dutch research, actually, from Wageningen and other universities. And they reached levels of about 1,000 terawatt hour or exajoules, which is more than twice the total energy use in the world today. But of course, this means a very large deployment of energy crops for mainly, which can of course be difficult. But it's more a question of how you do it than if it can be done. Next picture. One example of resources in our vicinity that haven't been used or tapped almost at all is abandoned farmland in Central and East Europe. This is a satellite analysis from a few years ago, done by mainly German researchers. They looked at these areas in Russia, Ukraine, Belarus, the Baltic states, Poland, and so forth. And they found about 30 million, between 30 and 50 million hectares of abandoned farmland that could very easily be used for growing energy crops like rape and grain, of course, that could be used for first generation biofuels, but they can also be used, as long as they're oil crops, of course, as raw material for jet fuel, for example. So this is an area that is equivalent to about 1/3 of the total agricultural land area in the European Union, which is around 100 million hectares. Next picture. The biggest potential, though, is really not abandoned land. it is increased yields on existing lands. And you can see here that in Northern Europe, we are rather close to what could be a potential yield. But if you look at areas like East Europe or Africa, they today produce only about maybe a quarter or maybe a little less a tenth of the potential yield on these lands. So that would, of course, free very large areas of land for production of biomass. And there are other factors, of course. One is in Europe is that the population is going to decrease from the rather soon compared to now. And also that maybe going over to a more vegetarian diet, also that would free quite a lot of land. So this whole idea of not using land for biomass production is totally flawed, I think. We can look at the final picture, I think. We can also see, if we look at the whole global picture, that there is an excess growth in the forests globally that is about twice as big as deforestation. So most of the forests in the world, except for certain countries in the tropicals, grow today more than they lose, so to speak, of biomass. So we have a growing stock of available wood in the global forests that also can be used. Sorry, I didn't show a Swedish picture, but that is just a little part of this.
No, but this is interesting because I think this is what we're talking about. Sweden is one thing, but the global the question is also if this is a solution for the world as it is as well. I should say that we actually asked the Swedish Nature Conservation Association to participate. Unfortunately, they didn't answer to the invitation, and we also asked WWF, and they didn't return either. So there's not really anyone here maybe talking against you, but we will do our best to ask some critical questions along the way, though.
No, but of course we would like, people have, and especially they do have different views, and there is a lot of talk about what really is sustainable to use and if there really is enough feedstock. And of course you have made it very clear here, but when you get these questions, these critical questions about there being enough feedstock and how we should use it, and is it really sustainable? Because I guess you get them to, what is your answer? I mean, part of it has been here, but what would you like to send along to us?
I would say that the first answer, of course, is that the European Union has very recently adopted sustainability criteria for biofuels from forests, and had them already before for biofuels from agricultural crops, for example. And I think that these sustainability criteria are quite good, and they should be applied. But I don't think that we should have other restrictions, for example, that it shouldn't be from farmland, or that there shouldn't be food or feed crops or anything like that. I think sustainability criteria are enough, and they can be applied internationally.
We're actually getting into that topic a bit later on here about RED II, for instance.
Yeah, I can comment later.
Yes, thank you very much. And this is really super interesting, and this is what we really are trying to corner again. How large is the availability, both of course of the feedstock and also then and then being able to produce the SAF itself. I would like to invite you, Magdalena, back in, because I have a question to you, and then we will be getting back to, as David said, to talk a little bit about the RED II, the European Union's RED II. But I just, you having been listening to this, Magdalena, and also being one of the biggest producers of sustainable aviation fuel in the world, in 2019, worldwide there was less than 200,000 metric tons of SAF produced. and that is equivalent or amounting to less than 0.1% of all the aviation fuel used by airlines around the world. Seeing these numbers, what are your thoughts about production in the future and how fast we can scale up and how we possibly can meet the future demand? What do you say, Magdalena?
Yes, thank you. It's a good question, of course, and we need to ramp it up quite quickly if we want to reduce GHG emissions, of course, when it comes to aviation, but also together with the electrification and hydrogen and so on. But I think, you can see now, because of, you can see Norway started with the mandate, SAF mandate last year, and Sweden will have one next year. There are discussions on EU level about a SAF mandate on EU level. So I think, with that, seeing there is a big demand for SAF, of course, companies like Neste and others, of course, see that, there is a potential to increase our capacity when it comes to production. And I think I said quite clearly in that we are doing that, and we see also others doing the same thing. Then is, of course, is a question about raw materials. I think Kjell did it really well, explaining that there is raw materials enough as well. There was actually a picture I saw, David. The next picture was how Neste see actually how we can, increase the numbers of raw materials. We actually increased our technology, especially when it comes to pre-treatment, so we can use even more and less quality of waste and residues. And we have made yes, oh, that would be so nice if I also could have a slide here that we can actually collect 35 million tons of waste and residues actually.
Was that the one?
Yes, that was the one for up to 2030, due to the fact that we have developed our technology so we can use less quality of waste and residues, but also that we actually improved our logistics so we can collect even more. But with that said, also that we're also looking for other alternatives as well. We see, as Kjell mentioned, also residues of forest and agriculture as coming raw materials quite soon, 3 to 5 years, but also algae, but also the new technology like e-fuels or power to X. But we also see the challenge. We need really a huge amount of cheap electrification, green electrification, and everyone wants to have that. So with that sort of maybe a longer term, but it can go very quickly, I would say now, even though there is just a small amount of stuff being used for aviation at the moment. When there will be, and it will be, a recovery of aviation, I think that will be sort of greener recovery, where the air companies and the business in aviation, they see we need to do this in a sustainable way. And I think, seeing not only Neste but other producers as well, seeing this as an opportunity to phase out fossil fuel, because we need to do that, but also to ramp up the production of SAF and other renewable diesel.
Thank you very much. You just hastily also mentioned that you're scaling up the ability to source or collect the feedstock, because that was also something we've been talking about, and we have heard that would also be one of the problems, because even if, again, there statistically is enough feedstock, it can be difficult to collect it, and it has to be in a sort of large systematic way to be enough.
Exactly, and it also needs to be, it can't be expensive, it needs to be sustainable and those things. But we see now that we need to work together with other partners. We can't work just Neste for ourselves. So together with partners, we are now we're seeing this sort of also circular economy, where, for example, we have a case in the Netherlands where McDonald's, they do fries and they're used cooking oil. We collect that, and that goes to the transportation used by McDonald's. So I think, you know, those kind of circular solutions, they will be needed, and you know, working together with others. So I think that's something we are solving actually on our way.
Thank you very much, Magdalena, for your comments on that. And we earlier on talked about the European Union, and RED II was mentioned. So Caroline, could I ask you to just, you know, briefly, I know it's hard to explain briefly what the RED II consists of, but, you know, a little introduction, and then give us your thoughts about how it will impact, well, both the production and of course the availability of SAF.
Yeah, well, thank you for the question. Maybe also for the persons who are not, so we speak about RED and then we speak about the Renewable Energy Directive. Maybe it's good to have a bit more context before I dive into the specifics of SAF itself. So, from next year onwards, there will be a revised version of the Renewable Energy Directive. There is already a first, and it's right now still active, of the Renewable Energy Directive. And the aim of this directive is to increase renewable energy production in Europe. It's not only targeting transportation, so renewable energy in transportation, but also other sectors, so heating and cooling, etc. But of course, for the sake of this webinar, it's interesting to look at the transportation sector. So in the first Renewable Energy Directive, the target was set that every individual EU member state had to have, of the total energy produced, 10% of it should be renewable energy. It's important to know that in the first edition, but also in this revised edition, so the Renewable Energy Directive 2, this obligation is actually set for rail and road sector. So not maritime, not aviation. In the first Renewable Energy Directive, so the 10% threshold should be met. And in that directive, there was not really an option for aviation, that even though the obligation is not for the aviation sector itself, that at least the aviation sector with renewable energy could supply to that 10%. So even though the obligation is not there, the aviation sector could still be a part of that 10%. Now we have the revised edition of the Renewable Energy Directive, and right now the EU member states can decide from themselves, because it's a directive, so it's not legislation. So in the end, every individual member state has to transpose it into national legislation. So every EU member state has to think, well, okay, right now we have a target for 14%. This obligation is once again for the rail and road industry. 14% of the energy in 2030 has to be renewable. How will we implement it? Right now, the option is there that aviation and maritime, so renewable energy volumes for aviation and maritime, can count towards this obligation for road and rail. So this is really interesting, because that means if a country is expecting or not to meet the targets via road and rail, or if they want to support renewable energy volumes in the aviation and maritime sector, they can do so using this framework. So this is the kind of the basics of the Renewable Energy Directive and the transport sector thereof. It's really interesting. So the renewable energy is there to also not only set an obligated volume towards these sectors, but also on the other hand to, for example, support technology pathways, but also feedstocks. So for quite a few, it's I think quite familiar to know that there's quite a crucial discussion always has been on the Annex 9 and on Part A and B. So the Annex 9 is actually a list of feedstocks. And then the Part A is advanced feedstocks. So these are feedstocks which the EU wants to see used more. So these are promoted. And the way that these are promoted is actually through the fact that the energy content of these feedstocks, while used for example, sustainable aviation fuel or renewable diesel, can be counted double, can be counted twice. This is also the case for the Part B feedstocks on this list, but the Part B feedstocks are being kept. So this is the Part B feedstocks are not for example, but those are UCO, used cooking oils, because what I said before, this is already quite a saturated market. So for that reason, that volume is being kept, and it's also the reason for animal fats. And in Europe, that's animal fat category 1 and 2. So in Europe, you have a categorization based on actually the disease level of the animal fat, so of the animal residues. And these are the residues which are likely to be contaminated with disease, etc. So which cannot be used for feed, food, or cosmetics anymore. So that's on the Part B, but those are being kept because that market is already quite saturated. So on Part A, you need to think about residues. So most is residues, not all. For example, algae is also on there. It's not a residue, but it's a promising feedstock. But other feedstocks on that list are, for example, biogas or tall oil. So those types of feedstocks you have to think. Of course, also agricultural residues, forest residues. Those types of feedstocks are on A, and they are being supported by the fact that the energy content of those feedstocks are being double counted. Then, because the European Union also wants to support the ramp up of the aviation and maritime sector, they decided for the aviation sector that if a country decides upon the transposition of the RED II in national legislation, that the aviation renewable energy volumes may count towards the 14% target in 2030, then in that situation, the aviation fuels can have a multiplier of 1.2. So that, for example, means that, and this can add up. So the double counting of the Part A and the multiplier of aviation, they can add up. So for example, if I produce, so the Netherlands accepts aviation fuels to count towards the 14% target. In the Netherlands, we have a bio-ticket system. That means for 1 gigajoule of energy, you can have 1 bio-ticket, and the bio-ticket is worth money. So we can fill the price gap with this bio-ticket. In the Dutch situation, that means, okay, so it's allowed to use the renewable energy for the 14% target. When I then use, for example, agricultural residues, and I make a sustainable aviation fuel, I fuel it into the market in the Netherlands. That means that I actually have not only the energy content can be double counted. So I'm not creating, for example, if I have 1 gigajoule, suddenly I have 2 gigajoule on paper. So I have 2 bio-tickets, but I can also multiply that with the factor 1.2. So then in total, my bio-tickets increase, and also the value in the end of the volume produced. So in this sense, there is a lot of incentives to promote sustainable aviation fuels in Europe. But the interesting situation is not all people, of course, like this list, because you can claim it's a fairly limited approach, because you actually say whatever is on this list is sustainable and what's not is not, whereas sustainable is often really situational. So it depends on the input factors, the situation, location, etc. So that's the one thing. The other thing is that people don't like the multipliers. Some say it's too little because it won't fill the entire price gap. The others are not happy with it because it's fictional. So yes, you support the sector, but it's not that there's more carbon being reduced. So it's all fictional. So we're now working, for example, the mandate system, but also if there would be an EU-wide mandate system, we should also revise all these rules, because these rules are great, but you don't need a multiplier if you have a mandate. Or maybe you then want a multiplier for the technologies which need an extra push to develop, or the SAF pathways which are more expensive. So then suddenly these RED II rules, they're there, but maybe aren't useless because we just have a different policy system. So it's interesting to see this system is right now in place, but what will be in place or what will be dismissed the moment that we have another policy system. So that's interesting dynamics we're now looking at.
Thank you. Very interesting, and I think you touched something that Kjell was talking about as well. Kjell, you have a comment on what can be used and not, and how land can be used and not used according to RED II.
Maybe we lost him. But still, I just wanted to say, Karin, thank you so much for running us through that, because I know it's not easy to describe RED II, but I think, again, you pinpointed finally there that because we have this list and it's defined what is sustainable, what isn't. So what we were wanting to ask Kjell again is it because it can also, of course, have regional differences. Something that can be a non-sustainable product in one area can well be a sustainable product in another area. So sort of, have a comment on if these, we need these global or European directives, but how well do they actually work in practice in different locals and regions? Anyone else from the panel would like to comment on that?
Magdalena here, I can do that because I think, there we are just now in the sort of implementation phase of RED II as well. And of course, there is a risk because of the food versus fuel discussion that, we have stricter criteria when it comes to sustainability, where food-based or crop-based will not be acceptable. And of course, as Kjell said, then you also said that there are regional differences as well. For there is a lot of land that is not used. Why not use that for producing really high quality? I'm talking for Swego's behalf now, because we use waste and residues. But even so, I think it's important that you have sustainable criteria, and that's and it should be climate clever. Sort of, you should it's about GHG reduction, and if everything is sustainable produced, that could be used. It's I think that's what we are a bit afraid of in Sweden, at least, because we use a lot of biofuels in Sweden, and we think it's a good solution, and we can see that it's actually reducing the emissions, in the transport sector and for aviation, and also how to, a member state can use, a mandate. Oh, now Kjell is back.
Yeah, he's back.
Yeah, but I just want to say as well, and then I will be quiet, I promise, but also that, in Sweden, we will introduce a mandate. So maybe we will not use the opt-in in that case, but those member states who's not having a mandate maybe can use the opt-in alternative in the RED II to get sort of the if you compare fossil fuel to biofuel, is not that expensive in that case, so, to try to get more businesses to use that. So I think, but with that said, for what we think should be an EU mandate, instead of not only a few in different member states.
That's right. And yes, Kjell, welcome back. You disappeared for a moment.
Oh.
Yeah. Hi. We have a bit of a storm here, so maybe we had problems with the electricity connection, which shows you that it's not always safe to be reliant only on electricity.
That's right.
You have to have fuel sometimes because they are always working.
Did we have the chance to hear a little bit about what Colleen was saying about RED II and about this list of these feedstocks are considered to be sustainable, then these aren't?
My comment to this is that in Svebio we are very critical of this kind of fake statistics and methods where you manipulate markets like this, and where you, from a political standpoint, decide on which raw materials are good and which ones are not. This will, in the coming years, become more and more problematic, because who is going to make these decisions? Shall we also make decisions on what technologies are favorable or not? We have a big problem right now. Within tomorrow, maybe, or next week, we will get what is called the taxonomy from the European Commission, where they will decide on what kind of investments are considered green investments and favored by by the European Union and which ones are not. And we know that they are excluding biofuels from the first generation. They will do that. But they will also create tremendous problems, I think, for the forestry sector. And all of this is because, just like we heard from Holland, in the working group for this taxonomy, they have all the leading NGOs sitting at the table, just like you do in Holland. And this is a dangerous method which will stop development in many areas, because these organizations often have prejudice about certain feedstocks, about certain materials, about certain technologies, and so forth. So I strongly advise against using that kind of administrative method. Things should be decided by democratically elected people and not by special interests. Thank you.
That's really super interesting to hear. And now, again, I think we're actually targeting what we wanted to talk about today, because on one hand, we also need to have credibility. We need to know that the SAF that we are using actually is sustainable. We need to have ways how to measure and how to certify SAF being just sustainable. And, you know, we have to rely on what we have and what we produce that is sustainable. And we've mentioned RED II, we have mentioned RSB, we have not quite yet mentioned, I think, ISCC, which also is a way of certifying sustainable aviation fuel. So really, now I'm putting out the question to whoever wants to answer in the panel. I can see that Magdalena is already waving, but because this is a problem, we do need to have we, for example, as a buyer of SAF, we need to be able to rely on that the product that we actually are delivering is sustainable. So how can we do that without certifications and guidelines?
Absolutely. I think, I'm sorry, I'm taking the floor, but because we are certified according to ISCC. So I think it's super important that it is certified, and everything, you know, sold on the Swedish market, for example, needs to follow very strict sustainability criteria. So I think sometimes maybe it's also up to us as companies to explain how we work with sustainability as well. I think we haven't, you know, because we know it's sustainable. And with that said, you know, there could be also, of course, things happen. We could have suppliers that's not following the code of conduct or our policies, but we always take that very seriously. We are on the ground, both supporting, but also, you know, working with local NGOs so we can, you know, find out if there are any problems. So I think maybe, you know, in the also RED II, and you know, you have those sustainability criteria, and let's have that. I think it's good, and I think, you know, we have to maybe inform more about that and how we work with sustainability, because, you know, there is there, and also you have to, you know, remind ourselves what we're aiming for, to phase out fossil fuel, and you know, you don't have any criteria for fossil fuel. So you have really strict sustainability criteria for biofuels, and that's good. But maybe we need to talk more about that, and maybe we just, because for us working with this is so natural.
Thank you very much. And I think, you know, I'm afraid our time is running out, and I think we've now just, you know, cornered down to why we think this discussion is so important, because we've, you know, we've come quite far. We've come far, you know, where we have established that SAF is something that we will be using in the future. And this is sort of the next step, how to increase the availability and how to increase production, of course, but also ensuring that it actually is sustainable. And I'm very, you know, sorry to say that we have run out of time, but the people who have been listening in, and also everyone in the panel, this is just one place where we meet and we talk about this, and I'm quite sure that this topic is something that we will continue discussing. I would, however, before we do our little rounding off here, David, ask Maria back in. Maria, can you hear us?
Yes, I can hear you.
Hi, Maria. So I just wanted to ask you to just give us your thoughts about what you've been hearing today.
I think what we can agree upon is that it is very difficult. I mean, when we talk about if there is enough feedstock, if it is sustainable enough, it's like talking about how long is a red what do you call it, string or something, because it depends upon so many different things. But what I think I heard here today is that sustainable aviation fuel can be sustainable, that we are working on criteria, that we are working on certifications, and that's important for us. And as you mentioned as well, Susanne, it's very important to get the belief from people that this is truly sustainable. And I think that's also part of the business model. It will be difficult to sell sustainable aviation fuel if it shows that it's not sustainable. So and that's also something that I hear. It's still growing market, or in some way an unmatured market that needs to develop, and that could be done with common demands on the EU level. But we also heard that it's difficult to blend the different, for example, then RED II and the quotas that we have started now in our Nordic countries. So that's probably something that needs to be looked into. What I would also like to say, as I think we have a very very interesting, say, 5-15 years in front of us. I think we will see many fascinating mixes of aircraft platforms, if I could call it that, with different fuels and different power sources that will mix and come together and give us the sustainable aviation that we all long for and that we all want to see in the future. And I would like to thank you all in the panel for being part of this movement, transition of the aviation industry, but also everyone that have been watching and coming with comments. We will look into the comments afterwards as well and answer the questions in the chat, I'm quite sure. Now I'm looking for you, David and Susanne. But it's also very good for us to know what kind of questions you have, and that we will continue, of course, to discuss this. This is not the last discussion in this area or this subject. So thank you very much for joining and helping us to move this forward.
Thank you so much, Maria. And of course, we also would like to thank the panel. And just a couple of final words. David, what do you think? Is it too complicated to deliver sustainable aviation fuel?
No, I don't think so. I mean, to one extent, it should be complicated because we want it to be sustainable, right? We don't want to replace the bad fuel with another bad fuel, because then we haven't gotten anywhere. So it should, to one extent, be complicated. But I think we have, like, the future, like, talks in our favor. I think we have all the chances to actually solve this, and yeah.
I think so too. I mean, of course, we have listened to all these different kind of certifications and regulation, and just, I mean, Kjell has made some really, really good and strong points there. I think the future lies ahead of us, and I would like to quote or refer to Mr. Robert Boyd from IATA last week at the IATA symposium, where they talked about this sustainable aviation fuel. He reminded us all of that the first commercial flight took place in 1914. It was between, I think, St. Petersburg and Tampa. And we put the first person on the moon in 1969. We've just been using sustainable aviation fuel for a couple of years. So I think the future does lie ahead of us. And I think even though it does sound complicated, these are hurdles that we will work through. And again, that we have to agree on, or do agree on, that SAF is a part of the solution, making aviation more sustainable, together with other things, of course. And it is important that we know that it actually is sustainable, and maybe a little bit of a challenge to get that insurance and certificate, but not impossible. So with those words, thank you everyone for listening in. And as Maria said, we will get back to you with the questions, asking them. I did ask people to ask questions through the chat in the beginning, but I'm afraid we have run out of time. So we'll answer as best we can. And again, of course, our panel, without you, we wouldn't have had a webinar. Thank you so much, and keep up the good work.
Thank you. Thank you for hosting this.
Bye all.
Bye-bye.
Thank you.
Thank you so much. Bye bye.
Bye bye. Thank you.